Hello everyone. This video will show how to change standard form equation of a line to its equivalent point-slope form. So what's going on here is that we are given the standard form of a line and we're supposed to transform it to its equivalent point-slope form. Before we go further, please feel free to check out the description below for the link of the other series of topics related to linear equation. Before we go over some examples, let's have a review on the basic information about the standard form of a line and the point-slope form of a line. Standard form. This is having a formula ax plus by equals c. Now we remember that our a should always be positive. This standard form is generally used to determine the x and y intercepts of a line. So if we have here this line, it touches on this point on the y-axis and this point on the x-axis. We can determine the coordinates of these 2 points using this standard form. On the other hand, we also use this standard form in solving systems of equation. So if we are given the slope of a line and a point, we label this as x1, y1. We can go ahead and determine the equation of this line by using the formula y minus y sub 1 equals m quantity x minus x sub 1, where our m is the slope and the coordinates x sub 1, y sub 1 is a point on the line. Sometimes the slope is not given, but another point is given. We can go ahead and solve for the slope of the line using these 2 points, and we still can use the point-slope form. We just have to pick which of those 2 points we use to replace the y1 and x1 in the equation. Okay, going back to the example right here, change this given equation of a line 2x plus 3y equals 12 to its equivalent point-slope form. Write at least 3 equivalent point-slope form equation. The first step that we're going to do is to change this given standard form here to its equivalent slope-intercept form. So I'm going to go ahead and write that equation down here. So this is in standard form, and again, we're supposed to change this to its equivalent slope-intercept form. So that means we are going to isolate y by itself on the left side. So I'm going to go ahead and subtract 2x from both sides, minus 2x. So then we can go ahead and cross out the 2x here. So we're left with 3y equals negative 2x plus 12. We want y by itself, so we're going to divide both sides by 3. We'll divide this by 3, and we're dividing this by 3. So then our slope-intercept form of this standard form right there would be y equals negative 2 over 3x plus 12 divided by 3 is 4. So this is the equivalent slope-intercept form of this standard form that we have right there. So I'm going to go ahead and write that up here. However, in this problem, we're supposed to write the equivalent point-slope form. So we go ahead and transform this again into its equivalent point-slope form. So I'm going to go ahead and write that up here. Okay, in order that we can change this to its equivalent point-slope form, we're going to break this 4 into a sum of 2 numbers. So we can go ahead and rewrite this as y equals negative 2 over 3x plus I can pick 5 minus 1. So that means 5 minus 1 is 4. So it's pretty much like breaking this 4 into 2 numbers such that its sum or its difference would be 4. So in this case right here, 5 minus 1 is 4. So we go ahead and distribute this plus to both terms inside the parentheses so that we can go ahead and expand this to be y equals negative 2 over 3x plus 5 minus 1. And that makes sense because if you have 5 minus 1 is actually 4. So what are we going to do here is that we are going to come up with 2 equations because we can either add 1 to both sides, or we can subtract 5 to both sides. So I'm going to go ahead and rewrite this equation to this side right here. So in this side right here, I am going to add 1 to both sides. So I'm going to go ahead and add 1 here, and I'm going to add 1 to that side as well. So our equation would come out, so we can cross this out. That would be y plus 1 equals negative 2 over 3x plus 5. Again, we wanted this in slope-intercept form, so we are going to isolate the m here, which is negative 2 over 3. So this would come out y plus 1 equals negative 2 over 3. Then we isolate that. We factor it out, so that would be x plus 5. Now, here's a trick. In order that we can, because if we distribute this is not going to come out 5. We can't take that 5 back. So what are we going to do is we are going to multiply this by the reciprocal of the slope. So that would be multiplied by negative 3 over 2. So then we can go ahead and simplify this further. So this would come out y plus 1 equals negative 2 over 3. Then we have x, and then 5 times negative 3 is negative 15 over 2. And we keep that as the answer. So this is one of the equivalent point slope form of this standard form that we have up there. Now, please remember that using this equivalent point slope form that we have right here, we can say that point 15 over 2 comma negative 1 is on the line. So I'm going to go ahead and write that down here. Now let's look at the second equivalent equation. So what are we going to do here is that instead of adding 1, we are going to subtract 5. So then we minus 5 and we minus 5 here. So our equation would come out. We can cross this out. That's y minus 5 equals negative 2 over 3x. That's gonna be minus 1. So then again, we go ahead and isolate or factor out negative 2 over 3. So this would come out y minus 5 equals negative 2 over 3. Then we factored it out, and then that's a minus 1. Again, the trick is you multiply this by the reciprocal of the slope. So that would be negative 3 over 2. And so we can go ahead and simplify this as y minus 5 equals negative 2 over 3. This will be x, and then this is negative times a negative is a positive, and then that is 3 halves. So this is another equivalent equation to this standard form that we have up there. So we also remember that in this equation that we have here, we can tell that point negative 3 halves comma positive 5 is on the line. So I'm going to go ahead and write that down here. Let's have some more equivalent point slope form equation of this standard form that we have right there. So in this problem that we have here, I wrote plus quantity 5 minus 1 because that is equal to 4. 5 minus 1 is 4. Now, what happens if we put a minus here instead of a plus? We can actually come up with another equation. I'm going to show that up here. So we can go ahead and write y equals negative 2 over 3x minus, then we are going to figure out two numbers such that it will give a negative 4 here, so that when you multiply negative times a negative, it will come out a positive 4. So one of those combinations would be 2 minus 6. You can have a lot of combinations from here. So you can have 1 minus 5, that is a negative 4. So, but in this example, let's just take 2 minus 6. Again, we can have infinite number of combinations. So in this case right here, we can go ahead and distribute this one right here. So that is negative distributed to the 2 and distributed to the negative 6. So our equation would come out y equals negative. That's gonna be 2 over 3x minus 2 plus 6. And that makes sense because if you have negative 2 plus 6 is actually positive 4. So then we are just expanding this. So then we can go ahead and again come up with two equations here. It's either we add 2 to both sides or we subtract 6 to both sides. So I'm just going to go ahead and write the equation up here. So in this side right here, I am going to add 2 to both sides. And in this case here, I'm going to subtract 6 to both sides. So this is how it's going to look like. So what I did here was I subtracted 2 from both sides, and so I'm left with 6 here. And so I go ahead and factor out the negative 2 over 3, and that is x plus 6. Again, the trick to determine when we factor out the slope here, we are going to multiply this constant we have here with the reciprocal of the slope. So that would be reciprocal. We flip it, negative 3 over 2. And so this comes out x minus 9. And so we can go ahead and say that positive 9, negative 2 is on the line. So I'm going to go ahead and show the same work on the side right here. But this time around, I am going to subtract 6 from both sides. Okay, so these two here are another equivalent point slope form of this standard form that we have right there. So if you notice, we have come up with 4 equivalent point slope form for that given standard form that we have up there. Now please remember that we can come up with infinite number of point slope form equation out of this general form that we have right there. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!